Hello friends, so here is another question on equation of motion. So it is given that a stone is dropped from the top of a tower 400 meters high, and at the same time another stone is projected upwards, thrown upwards vertically with a velocity of 100 meters per second. Find when and where the two stones meet. Okay, so this is the question. Now we have to convert it into a suitable diagram. Okay, so let us first draw a tower. Okay, so we have a tower which is 400 meters high. Okay, first a stone is dropped from the top of the tower with zero initial velocity. Dropped, nothing has been mentioned about the initial velocity. So here for the first stone, initial velocity is 0 meters per second. Then at the same time another stone, let's call it stone number 2, it is thrown upwards with a velocity of 100 meters per second. Okay, acceleration due to gravity is acting downwards. Let us say the two stones, they meet at this point. Okay, at this point. So this, let's say here the point from the top of the tower to this point, let's say the height is h, or the distance is h. So the remaining is 400 minus h meters. Okay, this. So this happens, this meeting point, this meeting of the two stones, it happens after a time interval of t seconds. Okay, after a time interval of t seconds at this point, which is at a height h below the top of the tower, and this is 400 minus h above the ground. Okay, now in these t seconds, stone 1, it travels a distance of ut plus half gt square, u1t plus half gt square. u1 is 0, so this becomes 0. So basically it is half gt square. This much distance this stone 1 travels, which is the height h. This, if we put g is equal to 9.8, okay, 9.8, then it will be equal to 4.9 t square, the value of h. So h is equal to 4.9 t square. This is a very important equation. So let us try to understand again. Two stones are thrown. Stone 1 is dropped with 0 initial velocity. Stone 2 is thrown upwards with an initial velocity of 100 meter per second. After t seconds, they meet at this point at a distance or height h below the top of the tower, okay, and 400 minus h above the ground. Whichever way you want to present it, it's all right. We calculated h is equal to 4.9 t square. Now, stone 2, it covers a distance of 400 minus h. Okay, for stone 2, the distance covered is S2 is equal to U2t minus half gt square. Why? See, stone 2 is moving upwards, direction of motion is upwards, direction of initial velocity is upwards, g is acting downwards. So g will be opposing the motion, they're in opposite direction. So that's why g is negative. For stone 1, direction of motion is downwards, g is also acting downwards. That's why for stone 1, g is positive. For stone 2, g is negative. Here initial velocity is 100, t minus, if we substitute 9.8, it will be 4.9 t square. Okay, this much. Now for the two stones to meet, 400 minus h, this should be the distance traveled by stone 2. So we can substitute S2 with 400 minus h, substituting the value of h here, 400 minus 4.9 t square. This is S2. For stones 1 and 2 to meet, this is the required condition. Okay, stone 1 covers a distance h downwards, that is 4.9 t square, which we calculated. Stone 2 covers a distance 400 minus h upwards. Okay, 400 minus 4.9 t square. So if we substitute S2 here, that implies 400 minus 4.9 t square is equal to 100t minus 4.9 t square. Okay, clear? So here 4.9 t square, 4.9 t square gets cancelled from both LHS and RHS. That implies we are left with 100t is equal to 400. That implies t is equal to 400 by 100, which is equal to 4 seconds. So one thing we have determined, both the stones, they met after a time duration of 4 seconds. Now we want to determine h. So simply we substitute the value of t here. H is equal to 4.9 t square equal to 4.9 into 4 square, 4.9 into 16, that is equal to, it is coming around 4.9 into t square 4 square, so it is coming around 78.4 meters. So both the stones, they met at this point. Okay, 78.4 meter below the top of the tower. Or you can determine 400 minus 78.4 meter, whatever the result is, above the ground. Both ways it is correct. Whether you say it 78.4 meter from the top of the tower or 400 minus 78.4 meter above the ground, either way it is correct. Okay, so this is a very good question involving motion of an object under the influence of gravity. So a lot of concepts are involved here. First, equations of motion, then sign convention. When acceleration and direction of motion in the same direction, g is positive. When the opposite direction, g is negative. That also came into play. And basic, common sense to use. Okay, so this is the solution.